evaluate the integral using partial fractions, integral x over x cubed minus 1 dx. Well, to start with, we obtain the partial fraction decomposition of the quantity that we want to integrate. All right, tell me, how do you break this down into partial fractions? The denominator is x cubed minus 1. Well, x cubed minus 1 can be factored. Now, how do you explain or expand a cubed minus b cubed? A cubed minus b cubed is a minus b times a squared plus ab plus b squared. Is that right? Now this is a cubed minus b cubed form. X cubed minus 1 is x minus 1 times x squared plus x plus 1. Right? Yes. So x cubed minus 1 is x minus 1 times x squared plus x plus 1. We have a linear factor and a quadratic factor. Now how do we deal with it? It will be a over x minus 1 plus, how do you accommodate the quadratic factor? It will be plus bx plus c over x squared plus x plus 1. So there you have a over x minus 1 plus bx plus c over the quadratic factor. But now we proceed as usual. Take the common denominator and simplify. And that will be, common denominator is x minus 1 times x squared plus x plus 1. And a gets multiplied by the quadratic factor. And bx plus c, the quantity bx plus c, gets multiplied by x minus 1. And we now have the denominator on the left equal to denominator on the right. Therefore, the numerator on the left must be equal to the numerator on the right. And there you have. And our aim now is to choose appropriate values of x to reduce two of the constants to 0 and find the value of the next one. Well, this is not as simple as the ones we have been doing. So we start by setting x equal to 1, and x equal to 1 will eliminate b and c. Is that right? Yes, because x equal to 1 will make this 0, and that means that will eliminate the whole of that. We can find a. All right, let's replace x by 1 in the identity. That will be 1 equal to a times 1 squared plus 1 plus 1 plus b times 1 plus c, bx plus c, times 1 minus 1. That will eliminate this. And what is inside here is 1 plus 1 plus 1, 3. We get 1 equal to 3a. There you go. Or a equal to 1/3. So we found the value of a. Now we need to find b and c. What do? To find b and c, we assign other values to x. You see, if you can find the two equations, we can solve for b and c. So let's see what we can do. Let's first of all start with x equal to 0. Remember, you can choose any value of x. It will be true, the identity is true for all values of x. X equal to 0 is a very convenient value. So let's replace x everywhere by 0. That gives you 0 equal to a times 0 plus 0 plus 1 plus b times 0 plus c times 0 minus 1. Now, what do these things amount to? This will be 1a, that will be a, and b will go, and this will be 0 minus 1, negative 1 times c. So the right side will be a minus c. Is that right? Yes. A minus c equal to 0 gives you a equal to c. If a minus c equal to 0, it means a equal to c. Since we know a, we also know c. A equal to 1/3, therefore C is also 1/3. Now that you know the values of A and C, you assign any other values to X and replace A and C, we can find the value of B. So let's say set X equal to 2. And that will give you 2 equal to A times 2 squared plus 2 plus 1 plus bx plus c is b times 2 plus c times 2 minus 1. And that gives you, this will be 4 plus 2, 6 plus 1, 7. 7a plus 2b, is that right? Now 2 minus 1 is 1, so there will be 2b plus c. Now 2 equal to 7a plus 2b plus c, but you know the values of a and c. A equal to 1/3 and c equal to 1/3. And therefore you get 2 equal to 7 times 1/3 plus 2b plus 1/3. And you can simplify that. We get 2b equal to 2 minus 7/3 minus 1/3. And that will give you b equal to negative 1/3. Now try it on your own. That's not very difficult. So I will give you the value of b, negative 1/3. So a equal to 1/3, c equal to 1/3, and b equal to negative 1/3. We can go and rewrite this expression in order to integrate it. So that will be integral x over x cubed minus 1, the left hand side, I know you cannot see it well, equal to integral of this quantity where we replace a, b and c, will be integral a over x minus 1, a is 1/3, plus bx plus c, b is negative 1/3, plus c is 1/3. So we just replaced a, b and c. Now how does that change? You can see, you can break it down into individual integrals. This will be 1/3 integral 1 over x minus 1 dx, that is the first term. And in the second term, we factor out a negative 1/3. Now remember, when a negative 1/3 is factored out from here, this x will remain positive and this will become negative 1, because 1/3 times negative 1 is negative 1/3. We factor that out. So negative 1/3 comes out. You have integral, what's remaining there is x minus 1 over x squared plus x plus 1 dx. Okay, now what do we do? The first integral is the standard integral, is that right? No problem. 1/3 integral 1 over x minus 1 dx is 1/3 ln absolute value of x minus 1 plus c. That's simple. But the second one is not very simple. Now, to evaluate the second integral, knowing that the derivative of x squared plus x plus 1 is 2x plus 1, we attempt to introduce 2x plus 1 on the numerator. Now, is it possible to write x minus 1 using 2x plus 1? Oh, well. First of all, look at this. X minus 1 can be written as 1/2 of 2x plus 1 minus 3. Is that possible? Well, you can see plus 1 minus 3 is minus 2. So 2x minus 2 is 2 times x minus 1. And the 2 will cancel. So look at the ingenious way that we are going to introduce the quantity 2x plus 1 on the numerator. Why are we doing this? Because the derivative of the denominator is 2x plus 1. If we have a 2x plus 1 on the numerator, we can make a substitution for the denominator as u. Now remember, when you make a quantity equal to u, we need to replace our dx in terms of u. That means you need to have a quantity on the numerator which contains the derivative of that denominator. That's the reason why we are doing that. So we're going to write x minus 1 equal to 1/2 times 2x plus 1 minus 3. Now, what change does it bring it there? And that will be 1/2 of 2x plus 1 minus 3 over 2. Is that right? Split into 2. Now, that will make it much easier when you write it. So, integral x over x cubed minus 1 now becomes the numerator x minus 1 is going to be replaced by this quantity. That's interesting. This is already we know, so we are leaving it like this. It is the second integral that we are interested in. So in the second integral, the numerator x minus 1 is replaced by this quantity. There you go. Okay, now we are back with this. We need to still fight with it. It's not easy yet. So we don't touch this. This is something that we can integrate. But the second integral, look at the numerator. The numerator is this quantity minus 3 over 2, which means we can split this into two integrals. So the first integral will have that as the numerator. And when you take that as the numerator, 1/2 comes out, gives you a negative 1/6. So that will be negative 1/6 integral 2x plus 1 over x squared plus x plus 1. Do you understand that? What I have done is, I split this into two integrals. The first one is integration of this quantity divided by this. And when you do that, take out that 1/2, which gets multiplied by 1/3, gives you 1/6, leaving you 2x plus 1 on the numerator, and the denominator is this. Plus, the second one is, why have this become plus? This is minus, this is minus, this negative 3 over 2 comes out, multiplies by negative 1/3, making it a 1/3, is that right? Well, we did not take out the 3 over 2, we left that 3 over 2 there. We only took out that negative. That negative with the negative become positive, and this now become positive 1/3 integral 3 over 2 over x squared plus x plus 1. I want you to look at this and learn that skill. We split this into two integrals. One is integral of 1/2 2x plus 1 over this. The next one is integral negative 3 over 2 over this. And the first one simplified to this. The second one, the negative become positive, simplified to that. But now, this can be integrated easily. How? If you put x squared plus x plus 1 equal to u, then 2x plus 1 dx becomes your du, because 2x plus 1 is the derivative of this. Alright, now we're going to make a substitution. Substitute x minus 1 equal to u here, and substitute x squared plus 1 plus x squared plus x plus 1 equal to u here. We're going to use u right through. They are not the same u, they are different u's. So this is our first u, this is our second u, and what we need to do here is complete square here. Well, you know how to complete square, don't you? Now look at the number of skills involved in here. So, let's complete square. X squared plus x plus 1. In order to complete square, what we need to do is take the coefficient of the middle term, that is 1, take half of that, that is 1/2, and square it, that is 1/4. So x squared plus x plus 1/4 is a perfect square. Now 1 can be written as 1/4 plus 3